Have you ever tossed your toy boat in the bathtub and wondered why it floats, but your rubber ducky's snack sank? Wait, was it made of chocolate? That might explain it. Today we're diving into the mysteriously floaty world of physics. We'll answer the age-old question: why do some things float while others sink like a rock or a meatball? Let's start with a simple idea. Imagine you're at the beach with a big watermelon. You toss it into the water, plop, it floats. But now you throw in a metal spoon. Kerplunk, it sinks. Why? Is it magic? Is it sorcery? Or maybe the spoon is just being dramatic? Nope, it's science. The secret lies in something called density. And no, density is not how packed your backpack is with snacks, although that is important. Density is how much stuff or mass is packed into a certain amount of space. Think of it like this. Imagine a fluffy pillow and a bowling ball that are exactly the same size. They take up the same amount of space, but the bowling ball is way heavier. That means the bowling ball is more dense. Now let's talk about water. Water has its own density, so when you drop something in it, the object has two choices. If it's less dense than water, it floats. If it's more dense than water, it sinks. Simple, right? Let's do some floaty thinking. A wooden log floats. A steel hammer sinks. A giant ship made of thousands of tons of metal floats. Wait, what? A ship floats, but a tiny hammer sinks? That sounds like a prank. But again, it's science doing its thing. Let me introduce you to the MVP of floaty science, Archimedes' principle. Sounds fancy, huh? This dude lived over 2,000 years ago and made an awesome discovery while, get this, taking a bath. Legend has it he stepped into a tub and noticed the water level rise. He got so excited he jumped out yelling, "Eureka!" which means, "I found it," probably with a lot of bubbles everywhere. Archimedes figured out that when you put something in water, the water pushes back. It gives a little upward push called buoyant force. So if the push from the water, buoyancy, is stronger than the object's weight, up it goes, floating. If the object is heavier and denser than the water, down it goes, sinking. Here's a fun visual. Imagine you're floating on a pool noodle. You're happy, life is good. That noodle is helping you stay above water because the noodle is less dense than water. Now swap that noodle for a metal bar. Sploosh! See you at the bottom. Ships float because, even though they're made of heavy metal, they're designed with hollow spaces filled with air. This spreads their weight out over a larger volume, lowering their overall density. So yes, a ship made of steel can float like a boss, while a tiny key made of the same steel will sink like it's been told a bad joke. Let's test your floatometer. Will an apple float? Yes. A paperclip? Nope. A can of soda? Well, that depends. If it's regular soda, it might sink. If it's diet soda, it might float. Why? Because sugar adds density, so diet soda equals less dense. Science is delicious. Now here's a curveball. Eggs. Put an egg in plain water? Sink. Put it in salty water. It floats like a champion. Why? Salt water is denser than plain water. Add enough salt, and the water becomes so dense, it pushes the egg upward. Eggs love swimming in salt spas. This is why the Dead Sea is so famous. It has lots of salt, making it extra dense. People can float in it super easily. It's like nature's beanbag chair. So what did we learn, float fans? Whether something floats or sinks depends on its density and how it compares to water's density. And don't forget the buoyant force. That watery push is a big deal. Want to impress your friends at lunch? Tell them, hey, I learned on Super Spark Science that a giant metal ship floats because of air and buoyancy. And by the way, don't eat rubber ducky snacks. They sink. And next time you're in the bathtub or at the pool, throw in random objects with permission and guess which will float or sink. You'll be doing experiments just like a real scientist, even if you wear no goggle. Haha. So the next time you wonder, will it float? Remember, if it's less dense than water, it'll float. If it's more dense, get ready for a splash. If you love this floaty adventure, dive into our other awesome videos. We've got glowing bodies, sneaky hiccups, and even brainy fish facts. Go ahead, click one before your rubber duck steals the spotlight again. Thanks for watching. And remember, stay curious, stay splashy, and never snack on chocolate ducks.